Hello students, welcome. Previously, lesson 4, from 4 to big 5, we were dealing with the chemistry of aluminum metal, where we have done the occurrence and also the extraction of aluminum metal. So today, lesson 5, our class will be mainly dealing with number 1, the physical and the chemical properties of aluminum, number 2, anodization and alloys of aluminum, number 3, the uses of aluminum, and we'll be concluding with 2 extended questions. So kindly stay with us until the end of the video. Let's start with the first part, the physical properties of aluminum metal. And we'll say number 1, it is lustrous. That means it's having a shiny white metal. So number 2, it melts at 660 degrees Celsius and boils at 2467 degrees Celsius. Next, we are saying it's ductile and malleable. Remember, we know the term ductile. We say ductile is a substance or materials which can be drawn into wires. Then what about malleable? We said malleable are substances that can be hammered into sheets. So number 4, we are saying it's a very good conductors of heat and electricity. Remember, aluminum is a metal, and we said metals are generally good conductors of heat and electricity, and that was due to the presence of delocalized electrons. Then lastly, we are saying it has a low density, or it has a relatively low density. And even we are told the density of aluminum is a third of the density of iron. We go to the second part of our class today, where we are going to see the chemical properties of aluminum. We are going to start part A, that's reaction of aluminum with air. We said polished aluminum is immediately coated by aluminum oxide. If heated at 800 degrees Celsius, aluminum burns in air to form a white border of aluminum oxide. We are going to get a white border of aluminum oxide. The equation for that reaction will be 4 moles of aluminum solid reacting with 3 moles of oxygen gas, giving us 2 moles of aluminum oxide, which is solid. Let us go to the second chemical properties of aluminum, that is reaction of aluminum with cooled water. We are told aluminum do not react with cool water and steam. The reason is that we are told this is due to the presence of a thin oxide layer of aluminum oxide formed as soon as exposure of air, preventing further reactions. However, it reacts with steam at temperatures above 700 degrees Celsius to form aluminum oxide and also hydrogen gas. Remember, learners, we said aluminum does not react with water and steam, and that's due to the presence of coating aluminum oxide, which prevents any reaction or further reaction from occurring. It was for this reason why aluminum was preferred in making cooking vessels like sofrias and also the pans. So let's see the reaction. 2 moles of aluminum solid reacting with 3 moles of steam, which is a gas. We are going to get 1 mole of aluminum oxide solid and also 3 moles of hydrogen gas. Remember, when a metal reacts with steam, the product that we are going to get is metal oxide and also hydrogen gas. Let's go to the third chemical properties of aluminum, that's reaction of aluminum with chlorine. We are saying hot aluminum burns in chlorine gas to form a white solid, which sublimes and is deposited on the cooler parts. So remember, we were having substance that undergo sublimation method or substance that sublimes. One of them includes aluminum chloride. So when aluminum, 2 moles of aluminum solid reacts with 3 moles of chlorine gas, what we are going to get will be 2 moles of aluminum chloride. So if this aluminum chloride is heated, it sublimes and it is converted to vapor, which will be deposited on the cooler parts. So that's anhydrous aluminum chloride. So the fourth chemical properties of aluminum is reaction of aluminum with dilute acids. So we're saying polished aluminum reacts slowly with dilute hydrochloric acid to liberate hydrogen gas and aluminum chloride. Remember, when a metal is added to dilute acid, what we are going to get is salt and hydrogen gas. So dilute acids are 3. We're having dilute hydrochloric acid, dilute sulfuric 6 acid, and dilute nitric 5 acid. Remember, What we are going to deal with when we are talking about dilute acids with metals are only two. That's dilute hydrochloric acid and dilute sulfuric acid. So when aluminium reacts with dilute hydrochloric acid, we get aluminium chloride and hydrogen gas. But when aluminium reacts with dilute sulfuric acid, what we are going to get will be aluminium sulfate and also hydrogen gas. So let us go to the question for the reaction between 2 moles of aluminum solid reacting with 6 moles of hydrochloric acid. We are going to get 2 moles of aluminum chloride solution and also 3 moles of hydrogen gas. So next we are going to go to anodization of aluminum. What's anodization? We are saying anodization is the process of thickening the protective coating of aluminum using electrolysis method. And we are saying in this process, aluminum is made at the anode in an electrolytic cell containing dilute sulfuric acid. Next, we are saying oxygen produced at the anode reacts with the aluminum, forming a thick and hard film of aluminum oxide on the metal surface. This gives increased resistance to corrosion. Then we are saying if electrolysis is carried out in the process of dyes, we are saying the result is colored, thick, and also tough oxide coat. This is used to provide a permanent decorative finish on a variety of aluminum items. That's anodization of aluminum. So during the exam, you can be told name an acid that can be used to anodize aluminum. So the acid can be dilute sulfuric acid. Next, we are going to go to alloys of aluminum. One of the alloys of aluminum is duralumin. And we are saying it's made up of aluminum, magnesium, copper, iron, and also manganese. Then it contains 95% aluminum, 0.5 magnesium, 0.5 manganese, and 0.4 copper. And we are saying it has better qualities than the pure aluminum because of 3 reasons. The first reason is that it is stronger compared to the pure aluminum. Number 2, it's more durable compared to that of pure aluminum. Then lastly, we are told it's more resistant to corrosion. So what is the use of this alloy of aluminum? So we're saying duralumin is used in the extraction of aircraft and car window frames. The reason why it's used in the extraction of aircraft and window frames is that 1, it is light, or we can say due to its lightness, or we can say due to its low density. Then number 2, we can say it is strong and hard. So for this reason, duralumin can be used in the extraction of aircraft and also car windows. Next, let's go to the uses of aluminum. The first use of aluminum, we can say it's used in making overhead cables. What is the reason? We have 2 reasons. 1, we can say due to its lightness, or because aluminum is light, or we can say it has low density. Number 2, it's a good conductor of heat and electricity. Yeah, aluminum is a metal, therefore it's a good conductor of heat and electricity. So because of this reason, or because of these 2 reasons, aluminum is used in making overhead cables. Number 2, used for making cooking vessels like sufriyas and bowls. The reason are 2. 1, it's a good conductor of heat and electricity. That's number 1. And number 2, it does not easily corrode by cooking liquids because of the unreactive coating of aluminum oxide. We have seen this one before. We said due to it is inapparent to react with water and steam, aluminum is preferred in making cooking vessels. So we are saying because it does not easily corrode. So number 3, we are going to duralumin, which is an alloy of aluminum, is used in construction of aircraft and car window frames. The reason we have seen a long time ago when we were dealing with alloys of aluminum, we said it is light or due to its lightness or low density, and number 2, due to its hardness or it is strong and hard. So number 4, we are going to go to corundum, which was anhydrous aluminum oxide, which can be called emery, is a natural oxide of aluminum useful as an abrasive. So number 5, we are saying its use in the thermite reaction for welding iron and steel. Number 6, we can say again its use as paint when powdered and suspended in oil. Then number 7, in the form of aluminum foil, it's used for packaging food, or we can say aluminum foil is used for wrapping foodstuffs. So lastly, number 8, we are saying it's used in making mirrors because we are told polished aluminum is very shiny and reflective. Okay, lastly, we will be going to the extended questions on the chemistry of aluminum. We have two extended questions. So number 1 is we are told the diagram below illustrates the Hall cell for the extraction of aluminum. Study it and answer the questions that follow. So kindly have a look at the Hall cell. We'll be proceeding to the questions. So these are the questions. It is from part A up to part G. We'll go to question number 2. So in question number 2, we are told the diagram below represents the second stage in the extraction of aluminum. This is from part A to part G. Then we proceed. We can have again E up to K. Okay, we proceed to the last part. That's from part L up to O. So learners, that's the end of our class today. Thank you for watching.